see on the right.
Oh. Hello? 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 Doesn't seem to be picking up. Hello? Can you hear me? Not good. Hello? Testing, testing. 1, 2, 3. Hello? Would it be better on the other side, mate? Oh, that's picking up a bit better. Is that better? That's picking up a bit more. Yeah. Right, can everybody hear me? Just make sure the mic's working okay. Yes, okay.
Not too loud, is it?
No, that's okay.
There is a sensitivity in here that changes a bit the menu, and you've got a sensitivity button there, which you can. Nearer to 0, obviously, the louder, but some 36 at the moment. So,
great. Right. Okay, brilliant. Thank you. Right, I'm passing the registers around. Make sure everybody signs them and make sure everyone comes back to me. Oops, that seems to have gone very loud. So if that goes down this side, that one can go down this side. That can go this side, and if that can go that way. Okay, I'm giving one up to the balcony. If the balcony one doesn't come back to me at the end, none of you are here, and you won't get a register up there ever again, as I said last week. So make sure you sign the register, and make sure all of the registers come back to me. If you miss it, I'll be outside with them at the end. Okay, first announcement, if you missed the test last week, you need to see me urgently, and you need to fill in extenuating circumstances forms at the office, and you need documentary evidence of why you missed it. I'm going to get the stuff, grades back to you and feedback back to you as soon as I can, hopefully feedback this week, and at the latest grades and scripts back next week, I hope. If we can manage faster than that, we will do. We're pretty close, but we're still working on it. But I'll get you that back as soon as you can. And once we've got you scripts back, then we'll kind of work with anybody who's not sure about why they got things wrong, or help everybody improve and fix things you don't understand. Okay? If anybody's got any specific things they want one-to-ones with me, I'm always outside lecture theatre, I try and be there from about half an hour before the lecture starts, and I'm always there afterwards for as long as it takes to answer every question. So if you want immediate one-to-ones, you can there. But get help from the demonstrators. They're not there just to mark in the Tuesday sessions. Those Tuesday labs are there to help people as well. So if there's things you want explanations for, ask the demonstrators to give you explanations, because that's what I'm paying them for, as well as marking. Oh, and the other thing, you don't forget the past sessions if you want extra help on top of that. They're on Wednesday lunchtime. Right, so what we were doing last week, we started to look at arrays, which are basically ways of processing bulk data. So I'm going to go back over that and take that a little bit further, and in particular we're going to go on to looking at algorithms, and our first sort of algorithm will be a very simple search algorithm. How do you search bulk data for something you need to find? And we'll look at a simple algorithm today, and then in a later lecture we're going to look at more sophisticated ways of doing this. So this is the first part of the course, which is everything you were tested on in the midterm test, is basically, this is the basics of programming. If you master that, you can more or less, with one kind of exception, write absolutely any program that needs to be written. You may not be able to write it very well, but you can actually write programs. There's a sort of theoretical principle that all you need to be able to write absolutely any program that needs to be written are, in terms of the plumbing parts of things, to do things one after another, so put one instruction after another, if statements to take a decision go one way or the other, and and loops, a form of loop that will do something repeatedly. A for loop isn't quite good enough to do everything you need to do, so in the second half we'll look at that and what you need more than a simple for loop, and what you need is something called a while loop, so that's the second half. But once you've got that, you can write any program. Everything else is about making programs easier to write, so you don't have to write incredibly long programs or incredibly convoluted programs. And as well, methods as well are there to make life easier so that it's possible to write the gigantic programs people write today. You know, so if you're just writing small programs like the kinds I can set you as exercises, you can get away with very little. But as you get to writing real software, real programs, you really need to do all this other stuff. So from now on, we're starting to get into the stuff where it's about doing this well. It's moving from just learning the sort of basics, like, you know, at primary school you learn the basics of how to read and write, but then you go on for years afterwards still studying English and ultimately get on to English literature. We're moving through stages like that with programming. And ultimately what we're going to get to is sort of some of the sort of fine things that are all about writing in programs well. You know, moving towards being the kind of person who would get a Nobel Prize for literature is the writing thing. So nobody ever stops learning to write unless you happen to have won a Nobel Prize for literature. The same goes for programming. And the more programs that you write, the better you'll get at it. But we're starting to look at subtleties. And when we get into talking about algorithms, part of the reason for that, we're picking some very simple algorithms that we can look at how you code them to see that there are subtleties about writing code, that you could write programs that do work, but just nobody would ever write one like that because in practice it just isn't good enough. Okay? So that's sort of what we're starting off here, going a little bit beyond just learning the sort of syntax and semantics of the language. So let me just switch things over. So let's just go back over a program that's sort of the kind of thing we were looking at last week. I can't remember if we actually looked at exactly this, but suppose what you're trying to do is process large amounts of data. And let me just go back to the idea of what an array is, just to refresh your memory about that. So up until now, we've been dealing with situations where we've got one box, and in that box you can put one thing. Okay? So if you declare an integer variable, it can hold one integer. We went to a slightly more complicated version of that with records, where we can kind of fasten different shaped boxes together so that we can combine an integer with a string. So we can have a student name with a student number and then present that as though it's just one box from the outside. All you can see is a box, but when you look inside, you've got compartments, and you can store lots of information about one thing. So I can pick a student, and I can store all the details about that one student. But what happens then is you start writing programs, and you start creating variables that are things called student 1, and student 2, and student 3, and student 4, and student 5. And you end up with a long list of variables, one for each student, or one for each car that you need to keep data about, or one for each kind of cat, or each kind of pet, or whatever. And so that leads to the idea we need some way of not storing lots of information about one thing, but how do we store different pieces of information about different things? And that's what an array is. It's the same sort of idea as a record, except it's sort of, in some ways, more flexible, and in other ways it's more restricted. But it's the same idea that what we're taking is lots of individual sort of variables, and what we're doing is we're essentially stapling them together. Maybe I've got a stapler which may or may not work, but what I'm doing... no, they don't make staplers like they used to. A few years ago that would have worked. Let's try with these two. This might work. Slightly thinner card. All right. So what I've got is now one box. And from outside it's just a single box, and I can give it a name. It can be the variable A, and I can always refer to it as A when I want it, but it's got multiple compartments. And if I can put more compartments on, then I can store more data. And the idea is each of these compartments stores the data about one thing. So it's student 1, student 2, student 3, and so on. But we just have one name for the whole thing, students. So the variable is called students, but we still have that idea of there's the first one, the second one, the third one, and that's what the individual compartment's called. So with records, we write a record class definition that sort of allows us to give names for each compartment. With arrays, the idea is it's actually a lot more flexible if you label the compartments with the numbers, just like we are doing when we write student 1, student 2 as variables. This is going to be student open square bracket 1 close square bracket. This will be student open square bracket 2, and so on. Except with one subtlety, we start counting from 0. So this is position 0, position 1, position 2. Okay? And with arrays in Java, you always start from position 0. Okay? You always count from 0. And that will be a common mistake people will make. So that's what's going on in this bit of code here. So what am I doing at the beginning? Actually, this is an old thing. There's two ways you can do that, and it's better, actually, to put that there. So what this is doing is you're giving a type and then a name of a variable. So I've called this variable myArray. I could call it anything. That's just a variable name, just like if I declared int a. But the difference is that the type is not int. It's int square brackets, open square brackets, close square brackets. And that open close square brackets just means array. So this is saying type integer array called myArray. So it's a variable declaration just the same as any other variable declaration we've seen up to now, except the type is an array type. And what this says is everything in the boxes are integers. And that's the restriction with arrays. What you do is you staple together boxes that are exactly the same size. Okay, so, and shape. They can only store integers. And you have to declare that in advance. So if you're going to create an array, you've got to decide what's going in it. Is it integers? Is it strings? Is it students? But whatever it is, every compartment's going to store exactly the same type of data. And that's the type that you give at the beginning that you write here. So I'm doing a declaration of a variable called myArray, and it holds integers. And what am I then saying here? I'm initializing it but I'm actually initializing the storage space rather than putting any values in. So whenever you use new, we'll talk about this a lot more in a couple of lectures' time, but when you're using new, you're actually saying, create me the storage space. And so the rest of this is actually a declaration of how much storage space you need. This is saying, we want storage space big enough for integers, and we want to be able to store 500 of them. So the square brackets are there again to say it's an array type that we're creating new things of. It's an integer array type, but 500 of them. And notice that number goes there. It doesn't go in the type at the beginning. The type is integer array, and that type doesn't give you any definition of how many storage spaces you want. But then, when you initialize the array in this sense, for the storage space of it, you say how much storage you want. And that's the part here. This is the part that actually says, okay, go and find enough boxes. Oh, I've got 2, 3, oh, I need another 497 from somewhere. Yeah. And what's happening in memory is you're finding a storage space that's big enough to hold that many integers all together in one block in memory. Okay? So what is that doing? It's just a declaration of a variable, but the variable is an integer array. Then the whole point of arrays, and why are we numbering them, the compartments, rather than giving them names like we did with records, is so that you can process them with a for loop. So for loops allow you to keep a counter. So what is this saying? Keyword for, it's saying keep a counter that counts from 0, keeps going up till 500 and stops at 500. So it will count from 0 to 499, adding 1 each time. So we'll count 0, 1, 2, and do whatever is in the body of the for loop that many times. So that basically says 500 times do that body. But the thing here is what we're able to do is use a variable as part of the sort of name of the array. So we can say my array, we want to go to that particular array, but we want to go to compartment I. And what is I? I is just another variable, some other box somewhere else that's holding a number. And that number is telling you which particular position in the array we're interested in, which of the 500 integers is the one we want to go to, or which of the 500 compartments. Okay? So you've got one thing which is the array, which goes on forever, 500 things along there, and then for my for loop, I've got a single variable I, and what is that doing? It's kind of a pointer that's pointing to a particular position. It's sort of saying, point to position 0, or if there was 1 in there, point to position 1 or position 2. It's keeping track of the position. So what we're essentially doing with code like this, if I've got a slide, feeling I might have got a slide yet. This is what I was... Essentially what we're doing is this. We're writing my array 0 gets some value, my array 1 gets some value, my array 2 gets some value, but the only thing that's changing about all of those things is that index, which position. So essentially, we're using I as though it was part of the name, but it's not I itself that's part of the name, it's whatever's stored in I. That number is stored in I that the for loop will change from 0 to 1 to 2 to 3 that says change something. So that for loop expands into 500 statements, essentially, each one with a different value of I to put in there. Okay? So going back to that, that's all that is doing. First time around the loop, I is 0. So essentially what we've got is one long array that goes forever, that's called my array, and it has positions 0, 1, 2, and actually put these in square brackets to show that they're not the values, they're actually the positions, the indexes we call those, and so on. And there's nothing in the array when we declare it, we've just created the storage space. And what this is saying is, I is the variable that the for loop's controlling. It starts with 0. So the first time we execute this, it says my array position 0, because I is 0, gets the value 0. Go to position 0, put 0 in it. And then I gets 1 added to it. I is now 1. And now we come into the loop. This says my array position 1 gets the value 0. Go to position 1 and put 0 again in there. And then come back here, add 1 to I becomes 2. Now we're saying my array position 2 gets 0, go to position 2 and put a 0 in there, and so on. Okay? So, before I move on, anybody got any queries at all about what that code is doing? Because if you don't understand these simple parts, you're not going to get much further. So if there's anything you're not sure about, stick your hand up, because other people will be confused too, I guarantee. Yes? Why are you filling everything with 0? Well, in this case, just because it's something simple, and quite often you want to fill the whole of an array with the same value to start off with. 0 is a common thing. It depends what you're doing with the array. All I'm doing is initializing it, so it's a bit like me saying int I gets the value 0 as its initialization. I'm just filling it with values, you know, and I'm assuming this is a program that maybe it's keeping track of how many students walked into each lab or something, and each position is a position for a student or for a lab or something. And so I'm keeping counters, 500 counters, and so each counter starts at 0, and when I see a student, I'll add 1 to it, and that particular position goes up by 1 or something. But there's no real reason why you always have to initialize with 0, but quite often it is the sort of thing you might be initializing arrays with to start off with. Okay. Any other queries about the arrays or the for loop or anything else? Okay. Oops. There is incidentally a shorthand for initializing things, where instead of writing new int, in this case 4, so instead of writing new int 4 and then doing a for loop like that that initializes everything to 0, you can just put curly brackets and a list of values, and that goes into position 0, that goes into position 1, that goes into position 2, that goes into position 3. Of course, if you're doing this with 500, it doesn't make sense to write all the values out. You probably want to use a loop to do it, but for small numbers of values, that's just a convenient shorthand instead of writing out a series of assignments or a for loop to do it. Okay. Okay, so now, basically what your question is about, well, what if you want to put other values in an array? Well, the fact that you're storing the index in a variable means you could possibly make use of the index. So it depends, oops, that's going off the side, isn't it? It depends on what your program obviously wants to do, but let's suppose what you actually wanted to store in the index was, in the array was just the position each time, which actually there are situations we'll possibly see later with various sorts of lookup tables and sorting using indexes that you would want to do exactly this. So if I want to put position value I in position I, what does that mean? If I follow this loop, so I'm assuming it's only got 4 positions this time, just to make it easier to do. What is that saying? Well, we've got something called my array with positions 0, position 1, position 2, and position 3, called my array. That's what that does. And now we have a variable I, that's controlled by the loop and starts with 0. And what does this say? I is 0, we go into the loop, my array position 0 gets the value 0. So position 0 gets the value 0, and then we add 1 to I is now 1, and so my array position 1 gets the value 1, that would put 1 into position 1, and then we could put, the next time round, it's 2, so we put 2 in position 2, and 3 into position 3, and so on. And so that's a very simple variation. It doesn't have to be the same value you put in every position if you can do some kind of calculation. Okay? So, any questions about that? Okay, if not, then what I want you to do is write a program that puts into each entry of array twice the value of its index. So essentially what I want you to create is a 2 times table. So it's a lookup table so that if anybody wants to do a multiplication, they can just look up the answer in the table and get it really quickly. So it's going to be very, very similar to the one we just looked at. I can get back, I can put it on the other screen. So it's going to be something very much like that. Just write me a fragment of code, so don't bother writing the whole program, just write me a fragment of code. That's more or less the same as this, but what I want it to do is hold the 2 times table. So in position 0 it should hold 0, in position 1 it should hold 2, in position 2 it should hold 4, in position 3 it should hold 6. And it's almost identical to what I've done there. And make it a 12 times table, if I haven't said. So it should have all the multiplication table from 0 up to 12. If anybody's got any questions or not sure what they're doing, stick your hand up and I'll come and talk to you. Yes. So you can use arrays to store records. Remind me if I don't, but I'll talk about that later. And all that you need to do is the record type. So if you've created a record called student, instead of saying int array, you say student array. And you've got exactly the same sort of mechanism. There's actually nothing new. It's just stringing together the mechanism for accessing array compartments and record compartments and getting them the right way around. Yes.
You know you wrote new at 4, and you made the size of the array.
Yeah.
Can you leave that blank?
No. When you do the new, the whole point about new is to get the storage space. So you've got to tell it how much storage space to get. And for arrays, it's a fixed size. When you create an array, you create an array of a fixed size. And so you have to decide when you declare it, or at least when you do the new, exactly how much storage space you need.
Can't you add to the array?
No. So you can't add new elements onto the end of an array. Array is a fixed size. Once you've created an array, it is that size. The only thing you could do with an array to extend it is essentially throw it away and start a completely new array that's now bigger. There are other data structures, all sorts of data structures that allow you to extend things. They're not strictly part of the syllabus, so you can go sort of explore them for yourself. As far as this module is concerned, what you do is just create an array that's big enough. So if I was storing information about every student here, I would go for 500, an array of size 500, because I know at most there's about 430 students, so 500 is bound to be enough. So just make it bigger, and then you keep track of how much you've filled it, is the easiest way. Obviously, for real programs, if you really do need to extend the size of the array, you're then better off using some of these more flexible data structures. But for now, make sure you can use arrays, and then worry about the other data structures afterwards. Okay. Any other questions? Yeah. In which case, come and see me at the end if you don't understand the explanation I just go through.
That isn't. And that means 10, that'd be 10 boxes in the array.
10 means 10 boxes starting from 0. Be very, very careful about this. 10 boxes starting from 0.
Okay.
Make sure you've got the right size array. I said it's going to be 12, not 10. I said 0 up to 12. So make sure you've got the right size array, and make sure your for loop is counting from the right start position to the right end position. I'll go through it in a minute, but think about that hard, because this is the way how people get arrays wrong.
You don't need to find the minimum value within an array. Can you explain that
I'll see, but that's an exercise to do that. There are examples, but I'll talk about it in general, or remind me at the break if I have a chance to. Okay, I'll go through this in a moment, so 30 seconds more. Sorry?
Basic effects. Up to 20.
Yes, basically that. If you have done that, you can be thinking about the second of these exercises. So, how do you do this? Well, it's essentially exactly what we had before. So, it's going to store integers, so it's an integer array that we want. Let's give it a name that makes sense, so it's times table, and it's the 2 times table, so I'll stick a 2 on the end maybe. And notice you can't start variable names with digits, so I couldn't call it 2 times table with a digit 2 at the beginning of a name. That's not a legal name for a variable. Right, what number do I need to put in there if I'm going to store the numbers from 0 up to 12? 13, yeah. Because if I want 12 times 12, but I've also got 0 times 0, that's actually 13 entries that I want. So that number there is always the number of cells, the number of entries in your array. How many compartments have my boxes got? Okay? And then we want the for loop, so for int I gets the value 0, I less than. So what is it got to be less than? (13) again. So what would that do? And then I++. What would that do? That's going to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And at 13, it will jump beyond the loop rather than going into the loop. And you've got to be very careful with your for loops about whether you put less than there or less than or equal to. So less than or equal to there would go one step further. It would go to a 13th position, and that would actually go off the end of the array. So what is this doing? We've got a for loop that's counting so many times, and now we've got to fill our times table array. So all we're going to want is an assignment times table to, at some position, gets the value something or other. Essentially, what we're trying to do here is make this for loop do the equivalent of lots of assignments. So essentially what we want is times table to at position 0 gets the value 0, times table to at position 1 gets the value 2, times table at position 2 gets 2 times 2 is 4, and so on, times table we want to get 144. Okay? So what we're trying to get this for loop to do is essentially that sequence of assignments. Each time around the loop, we want it to essentially do a slightly different assignment. Not exactly the same thing, a slightly different thing. So what's going on there? Well, that's just counting 0, 1, 2, 3, up to 12. And so that's basically what this variable I is doing in our for loop. This says start I as 0, do the for loop body with 0, and then add 1 to it so that I becomes 1, and then I will become 2. So the value of I is going to count 0, 1, 2, 3, 4, and so on as we go round the loop. So what do we want to put there? Well, a completely different number apparently, but it's just a calculation we want. Actually, what we want each time is 2 times something. 2 times 0 there, and 2 times 1 there, and 2 times 2 there, and 2 times 3 in the next one. And, oh, I did 12 times 12, didn't I? I meant 24 there. And 2 times 12 there. And so on. So what I've got is something that's exactly the same each time, 2 times something. So what I want to put there is 2 times something or other. And what is the something or other? Well, it's 0, 1, 2, 3, it's just I each time. As I changes, this calculation will do a slightly different calculation. It will be 2 times 0 the first time around the loop, 2 times 1 the next time around the loop, 2 times 2 the next time around the loop. Okay? So essentially what we're doing whenever we're thinking about a for loop like this is looking at what are the sequence of statements that we want to happen and slotting in a variable that changes the right way to go through the different values we want. So I will count through 0, 1, 2, 3, 4, 5 and so on, and as it does, this changes from times table 0 gets 2 times 0, times table 1 gets 2 times 1, times table 2 gets 2 times 2, because those numbers 0, 1, 2 are exactly what that variable I has got. So does that make sense? Basically what you're trying to do with a for loop and combining it with an array. Or is anybody actually still kind of bemused about this? Yeah? People are happy? So, all we're doing so far is putting values into an array. How do you get them out again? Well, essentially, if I wanted to print, having done this, if I want to print what is 2 times 5, then I can do that system.out.println, and what I've got to do is put something there that just goes to the, oops, I'm off the bottom, sorry. Put something there that goes to the right position in the array. So if I want to print out 2 times 5, because I've stored the answers in times table, I can go to this array times table. I'll give myself enough room here. And what I've got to go to is the right cell. And so what have I got? I've got in position 0, 0, in position 1, 2 times 1, in position 2, 2 times 2, in position 3, 2 times 3, and so on. So if I want what the answer to 2 times 5 is, I've just got to go to position 5 of the array. If I go and look in that particular cell of my array, what I'll find there is 2 times 5. So how do you get something out of an array? You just give the name of the array, square brackets, and the particular position that you're interested in. So it's essentially the same as we're doing to put things in. You're giving the name of the array, square brackets, and then in there is some expression that evaluates to a value, which is the position. So, any queries about that? So, if you understood what I was doing there, write me a code fragment now that prints all the entries in the array. So let's suppose what I want you to do is print out, having created that times table, I now want you to print out the table so that it can go into a book for primary school kids. This is your 2 times table. Okay? So how are you going to do that? Well, something like what I did there, but you've got to put that into a for loop. So basically, write me a little for loop that will print out the whole of this 2 times table now out of the array. So not doing the calculation now, just printing out the values in the array. And again, anybody got questions? Stick your hand up. I'll come to you in a minute. Oh, is that finished with? Did you get any of that? You sort of come and see me afterwards if you're not sure about stuff. Yeah.
Wouldn't it be better to use I less than 2 dot length? Because then you can change the
Yes, yes. So I haven't mentioned about dot length yet. It's the next slide. So yes. So in general, it's always better to have a variable, ideally a final variable, that gives you a value rather than putting hard numbers into your programs. But for arrays, yes, you can use the name dot length and that just gives you that value. But I want people to understand exactly what the value is so that they don't get confused between, well, is it 12, is it 13? Make sure you know what it is before you start substituting something for it. First and then you, no, because 2 times I is the same as I times 2, so you could put it either way around, it would do the same calculation. So be careful. You've got BODMAS rules on calculations of the order that you do calculations, brackets, multiplication, division, and then addition and subtraction. So if you don't put brackets in, you might, with a long calculation, end up getting a different calculation if you do things in different orders or without brackets or whatever. Yeah. So you would probably have an if statement inside the loop that says, are we on an odd iteration or an even iteration? So is I odd or is I even? Do one thing or the other, or something like that. One last thing. Yeah. So I is fine for counters of for loops because it's just a tradition that people have been doing for 30 years, calling the for loop count as IJK, basically. So in that situation, it's just well known that's what you mean. IJK always mean a loop counter. If you were using a variable as a counter in a slightly different situation where it wasn't just the counter in a loop, then you ought to give it a better variable name. I is fine if it's in a for loop, if it's the counter in a for loop. Okay? Right. Who hasn't signed a register yet, by the way? Everybody signed the register. Can the registers come back towards me as I'm going past? I can't read a program on the spot like that. Come and see me in the break or at the end, because I haven't got time to process it and debug it on the spot. Thank you. Okay, I still haven't got the register from the balcony, so make sure the balcony register comes down as well. Pass that down towards me. Okay, so how are you going to write a fragment that prints all the entries in an array? It's exactly the same structure that we've just done. It's a for loop because you want to process everything. And it's actually going to do the same thing of count I less than 13, I plus plus, because we want to go to every entry in the array. And then system.out.println. You could even be a little bit cleverer with this and say something like to times I is and then go to the array times whatever I called it, table 2, and which entry do I want to print out to get 2 times I is just the ith entry, so tag that on the end, close my for loop, and that's basically it. And we're doing exactly the same pattern over and over again, and this happens a lot with programs. Once you've got over the basics of learning the syntax and semantics, the meanings of individual constructs, what you're starting to see is actually doing the same thing over and over again. There's common templates or patterns of the way you write code. So whenever you're processing an array, if you've got to process every entry of an array, whether it's put things in or take things out, it's basically going to look something like this, that it's a for loop that runs from 0 up to the size of the array, and somewhere in the middle you basically process that array position I, whatever we mean by process. So whether that's setting values in it or getting things out, you're doing something or other that is on array position I. So the first thing to get sort of into your head about processing arrays is just that pattern of this for loop, naught up to size of the array, process the array, either assigning values to it or getting values out because you're going to print them or do something else to them. Okay? So any other queries about this? And this is the sort of common structure of how you probably most commonly use for loops as well. There are other situations you use for loops, but this processing them all with an array is the most common. Now there's one other minor variation. Somebody just asked me about this a moment ago. That actually, instead of putting that number there, there's a shortcut that every array comes with it in Java, a special variable that actually holds its length. So if you've got to create a variable called times table 2, if you put times table 2 dot length there, instead of the number, that is just a variable that holds the length of array times table 2. So the first part of the name is the name of the variable. The second part of the name is dot length. That gives you the length of that array. So if we call the array A, we could get its length from the variable a.length. If we called an array B, we could get its length from the variable b.length. Okay? Yes, sorry. So do you put less than or equal to there? So if you put less than or equal to, that means your for loop keeps going even when it's equal to that number, yeah? And if it's equal to that number, that's meaning it's equal to the length. But the array has that many cells, but they start from 0, so they finish one position earlier. So no, if you put less than or equal to, it would be the length minus 1. And we'll come across that over and over again. That is the most common bug people get with arrays. If you do something with an array and the program goes wrong, most likely what you did is ran off the end of the array exactly like that. Okay? Because the point is, if an array is of length 4, say, so that's an array of length 4, what are they numbered? 0, 1, 2, 3. The last time round the loop, I has got to have the value 3, not the value 4. So it keep going while it's less than 4, but when you get to 4, you've got to stop. So that's less than, not less than or equal to. Yeah? And these are subtleties, but you've got to get your head around exactly what's going on, and not just try and remember, oh, it's less than in this situation, it starts from 0 in this situation, but actually understand why. If you don't understand why, you'll probably get confused and you'll get it wrong. Okay? Any other queries? Great. What else? How are we doing for time? Okay, so one of the most common things that we use arrays for is actually to search for things. So let's suppose what I'm trying to do, I've got all of you lot here, and I actually want somebody, I want to find somebody in the room whose age is 35, okay? So I'm guessing not many people in here are actually age 35, but I've got to look. How can I find out? Well, in a situation like this, I could just say, stick your hand up if your age is 35. And what I would be doing is sort of parallel processing somehow all of you. A computer can't do that. All it can do is check one thing at once. So if I'm a computer and you're sort of an array of data, maybe it's just an array of integers, and in those integers, in position 0 is the age of student 0, and position 1 is the age of student 1. How can I find if anybody's got age 35? All I can do is this. I can go to the first person and say, are you age 35? No. And then I can go to some other person and say, are you age 35? No. Are you age 35? No. Are you age 35? No. Are you age 35? Are you age 35? No. Are you age 35? Are you age 35? No. Are you age 35? Okay. Anybody spot the problem in my algorithm? There's no order to it. I'm doing it randomly. And this is a perfectly good way of searching for things. And this is probably where the algorithm you use when you're searching for socks. You know, one sock's gone missing. You look in the first drawer, and then you look in the second drawer, and then you go back to the first drawer, and then you go to the bottom drawer, then you go back to the first drawer again because you don't quite believe it. And you're sort of just looking in places at random. But that's not a good algorithm because it doesn't guarantee you'll find it. You could end up just going round in a loop and never getting past some of the places. There were some places you could never search. So what's the better way of doing it? Just be organised. And what's the way to be organised? It's to start at the beginning and do it in an order, an organised way. Line everybody up in order and say, are you 35? Are you 35? Are you 35? No? Oh, I thought I was lucky then. Okay, and just go along the row one at a time in order from start to end. Okay? That way of searching is an algorithm called linear search. Okay? And what does it correspond to in a program? If you imagine, suppose I'm just searching the front row. This is just an array. You know, it's an array with a student, a person, but it could be an array with a number stored in each entry in the array. And actually, there's somebody there. I should have said, are you 35? And I would have crashed at that point because there's nothing there. But I look in every entry, and actually, we've even got numbers on our seats here that are the equivalent of the index. And actually, I'm betting that they don't actually start. What is your number? Ah, it starts at 3. God knows who. You know, clearly not a computer scientist. If it was a computer scientist, that seat would be numbered 0. Okay? Position 1, position 2, position 3, and so on. Okay? And that is linear search. And that's what the code up there is doing. So what is the thing where I'm going, is it you, is it you, is it you? What's making me move from one position to the next is the for loop. And what's keeping track of which position I'm in? It's the variable I. So each time we say I is 0, go to position 0. I'm going to stare at you quite a lot today, aren't I? So you go to position 0, I is 0, and what do? I say if whatever it is in that position equals the thing that I'm looking for. I can't see what I wrote there. So I wrote target. So instead of 35, I've stored it in a variable target. Are you equal to the target? Are you equal to the value of 35? And what I'm doing is a test. So that's an if statement. If he's equal to 35, I'm going to do one thing, otherwise I'll do something else. If I come off the bottom of that if statement, when I've done the if statement, I then do the loop, and the loop says add 1 to I, and that means go on to the next position. And so when I look in the array the next time round, again, I can't see it from over here. Why do you sit in this corner? You can't see a thing over here. So A, position 1, because I is now 1, I'm now asking the question here. The if question is now a test about this position. And then it's a test of the next position, and so on. So what this will do is, each time round the loop, it does that check, is it you? And if it is, it stores the result in this particular code I've written here. Where does it store the answer that I find? Yeah? Why don't I have the else? Because I don't need an else. And I haven't actually told you this, but you don't need to put else cases on your if statement. If you don't put an else there, it's the equivalent of else do nothing. So there is an invisible else there, but it's else, open brackets, close brackets, with nothing in it. It just is an instruction, do nothing. Okay? And this is actually the sort of situation where you do want to do nothing in the else case. Okay? Yeah. Good question. You tell me. So what does this program do when I find somebody age 35, or if I find a value in the array that has the same value as target? What does the code do? Does it stop? Keeps going, yeah. So what this particular code does, actually it says it at the bottom, it keeps going even after it's found it. So let's suppose you were 35, and I come to you and say, are you 35? And you say yes. What do I do here? If it is equal to the thing I'm looking for, all I do is I store the answer in a variable called result. So what is the position? It's 0, 1, 2, 3, 4, 5, 6. So you're in position 7. So I is 7 when I'm standing here. So I've stored that value in 7 into the variable result. But what do I do then? I keep going according to this program. It says, okay, are you 35? Are you 35? Are you 30? So even though I've found it, this program says keep going. There's nothing that stops the loop until it gets to the end of the array. So I'm going to keep going through all 500 or however many it is, whatever the length of the array is. Okay? And actually, what would happen if there were 2 people in this array that have got age 35? It overwrites the old version. I've only got one variable result, one box, and so if I come and find somebody else and it turns out you're 35, I basically scrub the 7 that I stole, throw that away, eat it, remember, jump on it, all that stuff. And what I do is I write a new position, 9, in the box. So what does this code do? Does it find every position, or the first position, or the last position? Where? Yeah? It finds the last position in the array that matches target. Okay, so it's like I'm looking for socks and I find a sock and then I keep going looking for another sock, keep going and find lots of socks and I only take the last one I find. Okay, yeah. Sorry. Why does it have 2 equals? That's equality. It's like dot equals, but for integers. So it's just asking, is AI, is what's in the array the same as the thing I'm looking for, the number 35? So equals equals is how you compare if 2 integers are exactly the same. If you're doing the same thing with strings, if I was storing names in the array, I would do dot equals rather than equals equals. But equals equals just means, are these 2 things the same? Sorry, you were first. Can you find out how many? Yes, so if you're going to do that, you would need to keep a running count and accumulate a variable where you add 1 each time you find 1. Yeah?
Store the first person that you find.
Yeah?
You just add a matrix so that the next time would say I equals the last number on that. Then it will just stop the loop.
So you need to stop the loop. I'll show you how to do that in a minute. If you actually, most often, you're going to want the first thing. This is a slightly silly, because there's not many situations you'd want to do this. So I'll show you in a moment. Any other questions before I go back up on stage? Everybody over here happy? Oops, was that a question? Yes? Shh. No, I'm not going to touch any other sorts of loops apart from pure for loops. Basically, loops, there are lots of different sorts of ways you can do loops. There are several ways you can do the equivalent of if statements. I'm only going to cover one. So basically, we've got the core thing in the syllabus. That's the thing I'm going to examine you about. You ought to go and explore. Once you understand the one, go and explore the other ways for yourself. So there are a whole bunch of variations on this, some that have actually been relatively recently introduced into Java, of different ways you can do it that make some things a little bit easier to do. But I'm going to focus on the core to make sure everybody understands the core really well. And that's what the syllabus is about. The syllabus is the core strand that if you understand that, you should be able to work the other stuff out for yourself. Okay? So I will be talking about while loops in a minute, but that's a different sort of loop to a for loop, and you do need to know about both, which is why they're both on the syllabus. Okay, so this is storing the position found into a variable called result, but then it overwrites it as we just saw. If what we want to do is stop when we found the thing, we need a way of stopping. And so there is actually a way of breaking out of a loop before you get to the end of it. And that's just this command break. So it's just a statement, and what it says is whatever the innermost loop you're sitting in, if you hit the break statement, jump out of the loop as though you'd ended up hitting the sort of end of the array, as though that test had ended up being false. So break says, if you execute this, jump out, but you'll only execute it if this happens to be true, because it's inside the if statement. So only if you do find the target will you ever execute the break. So if you find it, jump out. So that's a simple way of ending the loop early. When we do the second half and we look at while loops, we'll see with a while loop there's more flexible ways of doing similar things. Okay? So any queries about that? So break is a really simple thing. It just says get out early. And so the moment I got to that position, I would store the value of I7 goes in the variable result, and then I would jump out of the loop using the break and carry on. But you have to be a bit careful using break statements. Don't use them willy-nilly, because they can sometimes, with complicated loops, they can be hard to work out what's going on. Any other queries about that? Yes, because what's going to happen is I'm going to say, is it you, is it you? The moment I hit it, is it you, and the answer is yes, I go into the body of the if statement, and once I'm in the body of the if statement, I'm going to hit that break, and I'll just abort. I won't look at anything else. I stop as soon as I get to the thing I'm looking for. And there's another way you can do the same thing, actually, and this is more commonly the way you would do it in this sort of situation, if I've got the slide for this handy. So I'll leave this up while we have a break. Get it to the right place. So there's a variation which is now a method to do this, because searching is something you want to do lots. Why write that code over and over again? Why not write a method that does it and just call the method? So here I've written a method called search, which you give it an array to search, you give it a target value to search for. It's got the same for loop with the same if statement, but this time I return the value when I find it, and that return acts like a break, but out of the whole method. The return jumps out of the method, so you abort the for loop that you're in the middle of the moment you drop into the inside of that if statement. So it does the same thing essentially as a break, but now we're returning value rather than storing it in a variable. And that is actually the way you would search for data. So I'll leave that up while we have a break. I've overrun a bit, so where are we up to? I'll start again at 10 past. Anybody got any quick questions, you can come and ask me now. I haven't had a register from the balcony, so get that register back to me sometime in this break by passing it back down. Anybody got any questions, come and see me. Or I'll come to you. Yes.
I've heard a lot that using breaks is bad practice.
It is, except in very well-defined situations. So what I just showed you is one well-defined situation. Let me just switch this off a minute. Any other quick? Everybody sit down again. I'm just answering one last question.
Oh shit! I look like a lecturer now.
All right.
Where's the
I've got quite a loud voice. I've got a loud voice too,
Have
but
you
it's
got
not that loud.
voice?
What? No, my voice is definitely not loud, but oh well, I'll manage.
Oh,
Okay.
is that shisha pants?
Does anyone want
Wow,
to
yes,
start
I've
for
got
something
stuff up
first or
there.
what? Because I need to put the information. Do you think I'll be able to use one of his papers to put the information?
What information? What do you have to tell them?
There's basically an event for ITMB students,
Oh, okay. So
and I need a
engineering.
paper. Do you think I can write it on here? What can I write?
Find a blank piece of paper.
Yeah, and there's no blank piece of paper here.
And maybe if you use the marker pen, it'll be like, oh, you got one.
We'll go now then. Oh shit.
Yeah, we are going now.
Right, shut up. I've got guest presenters. If you stand there are mics there, so they all pick you up rather than having to faff with this.
What? Where's the microphone?
I'll say.
Just send it.
Okay.
Right, guest presenters, just for 2 minutes.
I'll say. Yeah.
Over to you.
All right. Can everyone hear me? Oh, see, just mic works, doesn't it?
So we're our first year course reps for computer science, and one course rep for...
software engineering for business.
I'm Michael,
I'm Eddie.
I'm Kieran.
Carlota.
and basically if you guys have any feedback, you want stuff changed, you want stuff done differently, you want events put on for anything like that, come speak to us. We're normally around, you can email us, whatever.
And then also there's an event next Monday from 6 till 8 for all ITMB and software engineering students. All the information is in your email, but otherwise my email, you know my email, I'm Carlota, I'm the only Carlota in the university, so you can send me an email or anything. And otherwise just find the information in your email.
Do you want to post something on the forum, actually, just
Yeah, I'll
introducing
post
yourself, and then everybody knows knows where to look if they
Okay.
can't remember?
Yeah, sure.
Okay?
All right.
Anything else?
Okay, great. Thank you.
Can I just reinforce that, actually? Yes. So if there are things you're worried about, generally about the course, or you think should be improved, then do tell them. So they're your way of being anonymous, of raising problems, and they are taken seriously. So they go to meetings with the kind of upper management of the school, and the upper management of the school have to take seriously anything they tell them about their issues. And the more they can say, well, lots of people think this is an issue, the more likely it is to be fixed. So if there are problems, if there are problems related to this module, tell me about them as well, because I will pass it up, I will fix anything I can, and I'll pass up stuff that I can't fix. But if there are problems that you've told both me and the student reps, it's much more likely to be fixed, because actually the reps are paid more attention to by my management than I probably am. Okay? And it's a lot more powerful if they raise these issues. Which reminds me, there was somebody that posted a question about why aren't you allowed in the labs when classes aren't running, because when there are computers free. So if there isn't a class there, you are allowed in the ITL in the labs. So if there are any machines where there's no class running, the place is empty, but the terminals are locked, go and report it to the ITL desk. If that's repeatedly happening, then let me know and I'll kind of try and fix it. The problem is we do have a lot of students, so there aren't actually that many slots in the ITL when there aren't classes. So you can find out when there aren't classes using the information that's on the screens, I believe. I think it's all up there outside. It should tell you when there are classes and when there aren't. Okay? But if that kind of thing is a problem, that is the sort of thing to report to the reps as well as telling me, because they may be able to get it fixed. Okay? And anything that's about, oh, you know, you're short of resources or anything like that, definitely tell them. Anything that you're unhappy about, basically tell the reps and let them pass it on anonymously. Okay? So there's one other thing about this particular bit of code, just that I'll point out. At the bottom it says return -1. So why is it saying return -1? First thing to notice, that's outside the loop. It's not in the loop. That's not done lots and lots of times. That's only done once. So why am I returning -1 once at the end of the loop? So anybody got any ideas? Why -1, and why do I need to do anything at the end of the loop? Yeah, you got an idea?
If you don't find it, then it will go through the whole array and then come out of the loop and then return -1. So.
Yes. So the point is, if I'm looking for something that's there, eventually I'll hit it because I'm doing it in this organised way, and I'll stop at the point where I found it. And then the inner return, the return I, will jump out, returning the position where I found it. I is just position in the array where the thing you're looking for has been found. But what happens if the thing isn't there? I'm going to run off the end of the array. And the method's still got to return something. But how do I know that the thing isn't there? I will only know that if I have run off the end of the array. If I've gone through everything and checked every entry, it's only at that point, when I've checked every single entry, that I know it's not there. So it's not something that I do inside the loop, it's something I do when I've got to the end of the loop and I'm outside the loop. So it's not an else case of the if, it's something that you do after the loop's finished. Just once at the end after the loop's finished. So why -1? Why? Is that some special number in particular? Could I just return 0? Could I return 66 or 42 or 27? You know, why would I return -1? Yeah, because that's not a possible position in the array. If I returned anything else like 0, you can't tell the difference between I found it in position 0 versus I haven't found it, it's not there. So you return something that could not be a possible real answer. So I could return something that's bigger than any position in the array. So if I've got an array of size 500, 501 would be fine. But that's not a general solution. -1 could never be the position in an array, because arrays start from 0 and are positive numbers up. So -1 is guaranteed not to be a position in an array, whatever the size of the array. So I return -1 with what's called a sentinel value. It's a special value that means something different. Okay? And here I'm using -1 to mean not found. Okay? So any other queries about for loops, arrays, and the simple ways we've looked at them so far? We'll keep coming back to loops and arrays over and over again from now on. One last thing, yeah?
I was just wondering, because Python -1 meant the first item counting backwards. Is that not true in Java?
Python...
Counting from the end, it would be the first item.
If you want to count backwards in Java, you would just count instead of I plus I minus minus, and you'd have to swap the I equals 0 and A dot length round. So there isn't any equivalent to what I think you're saying, but I might be misunderstanding you, of manipulating the for loop in some other way. And certainly -1 doesn't mean anything in terms of an index position. Index positions in Java are basically from 0 upwards for arrays. Other data structures, then other things might happen. Yeah.
Let's say that we set integer I equal 1 and we return 1. Could I do the same job?
So if we set integer I to equal 1 at the beginning, What would that mean? It would mean we wouldn't actually look at the very zeroth, the first entry in the array. So if the thing we were looking for was in the very first position, position 0, we wouldn't find it if we set I to be 1. And it wouldn't be, even if you were doing that, and you hadn't stored any data in that position, then it wouldn't be 1 that you would return. Maybe you would return 0 to mean the same thing. But no, in general, that's a bad thing to do. It's confusing. It would be code that other people would make mistakes if they had to modify. So in general, fill the first entry of the array, which is position 0. If you're going to return a sentinel value to mean not a position, use a negative value. Any other last things? Because now I'm going to move on to while loops. We'll come back, as I said, to this stuff over and over again as we go into more complicated things to do with it. Oh, one last thing, actually, that I was going to mention. So I've been putting off explaining, since the start of term, this thing about main having something called param whatever. Oops, and now I can't find the slides that I've got it on. So I'm actually now, finally, in week 6, in a position to explain exactly what's going on there. Oh, here we are. So here, when you've been saying public static void main string param blah blah blah, I've been basically refusing to answer in detail what was going on with that thing string param. And actually, what it is it's a variable declaration of an array. It's saying main takes as an argument an array of strings. Okay, so what's the situation where you would use that? You could write programs like this. Suppose you want to write a copy program that copies something from one file to another file. So actually Unix has got commands like this, and they're probably written in C rather than Java, but you could write the same kind of thing. So you've been writing commands or running your programs by saying something like Java copy. You'd compile it first, Java C copy.java, and then you'd say Java copy. If you put things after that, whatever strings you write there, whatever sequence of characters you write there, actually gets stored into that array of strings called param. So in file would go into param 0, the string copy file would go into param 1. So what is that? It's a way of having an argument that allows you, when you run the program, to give it some information that actually goes into the program and is stored in a variable. So basically, main comes equipped with an array of strings. All the programs you've written so far, it's just been empty. You've not passed any information because you've always said the equivalent of Java copy without anything after it. But if you said Java copy 1, 2, 3, 4, 5, for example, that param array would have in position 0, 1, in position 2, 1, and in position 3, I've lost track of what I said. It would have that sequence of values that you put after you wrote Java copy. So that's a slight aside, but I kind of promised that I would actually explain that at some point when we got to the stage where we'd done enough. And all it is an array declaration. It's just an array declaration that's a parameter of main in the same way you've been using parameters for other things. Okay, so what are we going to do now? I'm going to type my slides, but what we're now going to look at is a different kind of loop. So a for loop, a pure for loop, isn't actually quite powerful enough to do every program you might ever want to write. And I'll show you why that is in a moment. But it's basically for loops are for when you know in advance how many steps you want to take. So you know you're going to do something 50 times, or you know you're going to do something 500 times. And you can use break or return to stop early, so there's a little bit of flexibility, but not much more than that. So if I just sort my slides out. Oh, actually, there was something else I was going to tell you. This is partly to do with midterm tests and so on. Well, I've sent a message to the forum overnight this morning. Basically, now is the time to dig in. However hard or easy you found the midterm test, don't take a breather now and think, okay, we've got 6 weeks until the next test. The only way you're going to do well is if you keep working. If you found it really difficult, a lot of people are in the same position. It's early days, you've still got 6 weeks or so to go before the end of term. I care about what you can do at the end of term, not what you can do now. Okay? So your grade might be capped if you did really badly, but essentially it's what you do at the end of term that matters. Nobody has failed at this point. Okay? And I'll talk, once we've given the feedback and the grades and your scripts back, I'll talk through with anybody who's worried about where they're at, and we'll help anybody as much as we can. But there's one thing I want to say, and I usually do this in about week 2 or 3, and I forgot this year, but there's something that's really important to realise. So the first thing is anybody can learn to program. Some of you are starting a long way further back than others, so don't get freaked. I did say this, don't get freaked by the people who are finding it easy, but use them as a resource. Yeah, okay? On the exam, I expect you to be able to explain things as well as I can. What do I mean by explain? I mean teach. So practice explaining now on each other. So if you understand it, explain it to somebody else. Because in doing that, you will get a better understanding yourself and you'll have practiced explaining stuff. And if you didn't understand something and somebody explains it and you do, explain it to somebody else as well. But now is the time for work, basically, not to have a breather. Okay? And just as a sort of anecdote about this, has anybody heard of the marshmallow experiment? This is a famous psychology experiment with marshmallows. Maybe? No. Okay, very quickly, marshmallow experiment. It really matters that you understand this. So it's years ago, but some psychologists did an experiment with 4 or 5-year-olds where basically they brought a 4 or 5-year-old into a room and there was a table there, and on a plate was a marshmallow or some other sweet. If they were doing it with me, they'd have to do it with chocolate, not marshmallows. But anyway, so some kind of sweet on the plate in front of them. And the researcher basically says to the child, okay, I'm now going to go out of the room, and while I'm out of the room, that marshmallow is there and it's yours. You can eat it if you want to, but if when I come back the marshmallow's still there, I'll give you a second one and you can eat both. Okay? And what they did this to lots and lots of children, and then just recorded whether they ate the marshmallow before the person came back or not. And if they did eat the marshmallow, they got the one on marshmallow, but they didn't get the second one. And that was fine. That was all they did. Except they then came back about 15, 20 years later and tracked how successful all of those kids had been. And what they found was the best predictor of whether somebody's going to be successful in life is not their intelligence, it's not their background, it's not their IQ, it's not what their parents are like, it's not anything like that. The most best predictor of whether somebody's going to be successful in life is whether they eat the marshmallow when the person goes out the room or not. Okay? And what it's about, basically, is the best predictor of how successful you're going to be is how good you are at resisting temptation, as opposed to doing kind of stuff that you're not really finding very good or easy or want to do. Okay? So if you can resist temptation, you will be successful in life. Okay? So now is the time to think of the next few weeks as being a gigantic marshmallow. And the Draper's Bar is a big marshmallow. Nightclubs are gigantic marshmallows for some people. You can either eat the marshmallow and then maybe you'll be, I don't know, stacking shelves for the rest of your life. Or you can not eat the marshmallow, you can do some work, you can write some more programs, and then there will be really big marshmallows, i.e. a wonderful job at the end of it, or more immediately you'll be able to program. Okay? It's about putting work in. Programming is not about talent, it's what I said when we were talking about juggling. It's about how much work you put in. Bearing in mind, some of you have started a little bit further back than others, so it looks like you're behind, but you're not. Go at your own pace. Do things foundationally. But what you can't do is have a breather at this point, because if you have a breather, that is basically taking a marshmallow. Okay? And, you know, it's up to you. If you want to eat the marshmallow, that's fine. I've just told you the consequences of eating marshmallows too early now, just to make sure you know. Okay, so, that said, you can think about that. That's how to be successful in anything in life. Don't eat the marshmallows. Right. Skip over a few things. What I'm going to talk about now is a different kind of loop. So for loops are when you know exactly in advance how many times you've got to do it. We're going to do this 500 times. But that's not that's not enough to do everything you'd want to do. So just to motivate this, here's a bunch of different problems you might have to do. One of the first programs I ever wrote for myself was a dice game program. It was to play dice cricket. When I was at school, we used to play all the time this game with rolling dice where we were sort of playing a simulation of cricket. We spent hours and hours doing this. So when I started to learn to program, one of the first things I did was write a program to do the same thing so I could play this game on my own. And didn't, you know, who needs friends? You can play things on your own if you've got computer programs. And there's all sorts of variations of games you could play. So I brought a dice, and actually, with a bit more time, I'd get a volunteer, but I'll do it myself. You know, I've got a dice. It's a really good dice. I made this myself. And what kind of game could we play with a dice? Well, the first one is a game where we take it in turns, maybe, but each person gets to roll the dice 5 times, and then you get the highest score. So how do I do that? I roll the dice, I've got a 4, and I need to keep a running score. I roll the dice, I've got another 4, add that onto my score is 8, and I've got a 5, 8, 9, 10, 11, 12, 13. Oh, and I should have been keeping a count, shouldn't I? So what have I got up to? I is 4 now. I've added 5 on, and I'm losing track already. Who knows what my score is? I roll again, and I've got a 6. I've done it 5 times. Take that score. If I wanted to write a program to do that, we can already do that. So this is basically just a summary of what we were doing already. Am I on the wrong thing there? Let me get to the right thing. So, I want to do it 5 times. I want to do something repetitively. It's easy, it's just a for loop. So, for int I equals 1, I less than or equal to 5 says do it 5 times. Notice I'm counting from 1 this time, so I'm using less than or equal to. I plus plus, there are no arrays here, so I can count from 1. And what do I need to do? I need to keep a score. Let's suppose I've got something that throws a dice, so I can say int roll gets the value dice. So that's just some method I've written separately to do this. It's in the handbook if you want to find it, and there's a whole booklet about random numbers and rolling dice. And then what I need to do is keep a score, so I need to say score gets whatever the score was the last time round plus the current roll. So plus that value, and of course I need to set the score to 0 at the beginning. So that's sort of really just a refresher. That's another exercise of using a for loop. But that works because the question says, the game says, you get to roll 5 times. I know when I write the program, that loop's got to do it 5 times. Okay? So the for loop uses the uses the counter I as my fingers to say, okay, I've done it once, okay, I've done it twice, okay, I've done it 3 times, and so on, okay? And I know when I get to 5, I stop. So that's what for loops are for, when you know how many times you're going to do it, when to stop, which is why they go with arrays, because arrays have a fixed size. You always know when you get to the end of the array, you're going to stop, okay? But if we look at any of these other problems, you can't use a for loop. I don't know how many times I'm going to roll the dice. So the next one, roll the dice repeatedly and ask if you want to continue each time. So I'll ask you whether you want me to go on. I roll the dice and say, do I go on? Yes, okay. I roll the dice. Do I go on? and I roll the dice, and do I go on? No. Okay, I stop. I don't know when I start how many times I'm going to do that. I can't use a for loop, not a pure for loop, to do that. There is a sort of bastardized form of a for loop that you can use, which is not good practice, where you could turn a for loop in Java at least into something like this, but a pure for loop you can't do that with. Of course, I don't know, we could have gone on for 1,000 times there before you said, no, you want me to stop. Or I could have just done it once, or I could have done it 7 times or 8 times. I don't know, and I can only find out by running the program, and it will be different every time I run the program. So a for loop isn't good enough for that. If we look at the next one, roll the dice repeatedly adding the scores, keep going till you get a score of more than 21. So this is kind of dice pontoon or something. So what am I doing now? I roll the dice, 3. How many times am I going to roll the dice? I don't know, but let's keep trying. I've rolled once, 4. That's a 5, so I'm up to 9. And a 5, I'm up to 14. And a 6, I'm up to 20. And a 6, oh, I've gone above 21. So there, I've kept track of how many times I've done it, but again, I don't know how many times I'll roll the dice. I could do it in only 4 goes. I could take 21 goes before I get up to 21. Depends what the roll is. So again, it's completely different situation to what a for loop can deal with. I just don't know when I'm going to stop. Same with the next one. Roll the dice until you roll a 6. You know, so again, I roll a number, it's not a 6, so I keep going. I've no idea how many times I'm going to roll. Ooh, I stop until I stop. Roll the dice until you stop. Roll a 6 and you get 0. Get as high a score as possible. Is another variation that's getting towards a more realistic games. Okay. So, a for loop is not good enough to do anything but that first version of that one game. And the same sorts of situations as these games crop up over and over again. So if you get sort of a way of doing each of these things, you've got a template for solving half a dozen different problems that are nothing to do with dice games, but are exactly the same situation you'll keep coming up with. So, what do we need? We need a different sort of loop, a different thing to do repetition that isn't this for loop with a counter going up to some fixed number and then stopping. So what is common about all of this? There's 2 things that are common actually. All of them have got something to do repeatedly. There's something that I'm doing over and over again. I'm rolling the dice over and over again. I'm adding to the score over and over again. There's some things that I'm doing over and over again. And all of them have got some condition that they tell you when to stop. It's not when you get to a count getting up to 5, but it's when something happens. So in the first one, it's when the user says stop, when an input is stopped. In the next one, it's when a total gets up to a particular number. In the next one, it's when the actual dice roll gets to a different number. There's also variations where you input a value and where that input value is different. So what we've got is a test. There's some test that says when to stop. And actually, that's what's going on in the first case as well. There's a test of when to stop. It's when you get up to 5 with the counter. So if we're going to come up with some general way of doing this, put yourselves in the position of the people inventing the first programming languages in the 1950s or so. They had to solve this problem. They've got to invent some kind of construct that allows them to do things repeatedly. There were 2 things about it. One is you've got to say what it is you want to repeat, and the other thing is you've got to say when to carry on. Or when to stop is the other way of thinking it. Okay? But those 2 things. And a third thing you need is actually something that says this is what we're doing. Here we use the keyword for to mean we're going to do a repetition a fixed number of times. I need some other keyword instead of for that is going to say we're going to do this different kind of loop. And what it actually is while. We use the keyword while to mean we're using a general form of loop. Okay? So, what does that turn into? Well, essentially, what you want is something like this. You could invent a different keyword and you could invent different brackets and whatever, but essentially, if you're going to do a general mechanism in a programming language to say do things over and over again, you've got to have something that you're going to do over and over again. You've got to have a keyword that says this is what we're doing. We're doing something that's a repetition. And you've got to have a test that tells you when to continue. Those are the three elements. And in Java and most programming languages, you use the keyword while, you then put the test using some kind of brackets to say what it is. We'll use exactly the same kind of syntax for an if statement, which was also a test that's either true or false. So if this test is true, we want to do this again. If this test is false, we finally decided to finish. So what this is going to do is you'll come into the while loop from whatever instructions are before it. You'll do the test. If the test is true, you'll do the instructions you want to repeat. And then you'll go back and do the test again. And if ever the test is false, then you'll just drop out of the loop and carry on with whatever comes after it without going into the body. And how do you know what are the instructions to repeat? Well, we'll use the same syntax as we've used to group commands together, the curly brackets again. In some languages you'd write begin and end, but what you want is something that's consistent. Everywhere where we've grouped commands together we've used curly brackets, that's what we'll do here. And that's basically, with that loop, with that in your language, you can write any program you need to write. It's good enough to do any kind of repetition whatsoever. Whatever dice game you invent, that loop would be able to do it. Okay? So, any questions about anything I've said so far about what that while loop is about? Because these are quite tricky to get right. So the way to get them right is basically to then start thinking through templates. Learn a bunch of templates of common ways of using a loop. And chances are, when you're using a while loop, it will be one of those common templates from lots of common situations. Okay? But the main thing is to understand what it does. What it does is the instructions in the body, it's going to do those lots and lots of times, but you don't know how many times in advance. You just keep doing them until that test ends up false. If it's true, you do it again. True, do it again. True, do it again. False, okay, we can carry on with the rest of the program. Okay? So anything anybody doesn't understand about what that's doing before we look at some examples? Okay, how am I doing for time? Okay, so let me actually go through some of those dice game examples and look at how they might turn into a use of a while loop like that, just like my for loop was. So let's suppose I'm doing the second one. Roll a dice repeatedly, ask if you want to continue after each roll, and what's your score. So we're going to do something repeatedly, so we're going to use a while loop. And what we need is a test, and we need something to do over and over again. So let's focus with what are we going to do over and over again. Well, it says roll a dice repeatedly, so we're going to roll a dice over and over again, so that's got to be inside our body. It's got to be inside the curly brackets that are saying what's going to be done over and over again. So maybe we're going to say int roll gets value, and we'll call my method dice that just rolls the dice. Okay? So that's going to be done over and over again. But I've also got to ask if you want to continue, and that's got to be done over and over again as well. So what I'll do there, something like answer gets the value, input, continue, yes or no. Okay? So I'm going to ask, do you want to go again over and over again? What else do I need to do? Well, I've got to keep a score, and so that's going to be just adding the roll on. Score gets, it's just one of these accumulators again. Score gets score, and add on the roll, and that will keep track of the score. Okay? And that's basically what I've got to do. Roll the dice, add it onto the score, and then ask if they want to go again. Okay? So, question then is, what is the test that tells me to carry on? While what is true, do I carry on? So it's about answer. I want to carry on while the answer is yes. So my test to carry on is answer dot equals yes, or y. So while answer equals y, roll the dice, add it to the score, and get a new answer. Ask them, do they want to continue? If they say yes, the next thing we'll do is this. And then we'll do it all again if they answered yes. If ever they answer no at this point, the next thing we do is that. If they answered no, we would then immediately jump out and carry on with the rest of the program, which might be something like, I don't know, print your score is score or something. Okay? So only when this test becomes false do I jump beyond the body and end up doing what comes after. Now there's one other thing that I've missed about this, and this is the common thing that people get wrong with loops. So if I just lose the bit from the bottom that's just printing the answer, what else do I need here? Well, there's two things. I need to initialize a bunch of variables. I haven't actually initialized score, and I haven't declared it. So actually, I only want to do that once. I don't want to set the score to 0 over and over again, because that would lose the score. So outside the loop, I want to set score to 0 to be the initial score, so that then the first time I get here, there is actually a value there to add to, and it's just 0. But there's also answer. It hasn't been declared either. And I can't declare it here because I actually need it again as the first thing when I come into the loop. The first thing I do is test answer. So I've got to have an answer before I start. So what I could write is string answer gets the value yes. Make that a string. Oops. And what have I done is I've initialized it to a value so that the first time we ask the question, it's set to yes just by default, which will allow me in to roll the dice the first time. So that is a really common structure to a repetition. Not just playing dice games, but all sorts of places. You want to keep going until somebody says stop. So you ask a question at the end. The last thing you do is ask the question. And your test is, was their answer to keep going or to stop? But you've always got to remember outside the loop, before you start repeating things, to set an answer that will let you into the loop. Okay, so anybody got any queries about that program? So it's very similar to a for loop, but it's a for loop which has got a much more general way of stopping. And you can put anything you like in that test as long as it's true or false. Yes. Shh. So you could have a Boolean to represent yes or no, but if the person was typing things in, they're going to type in a string, so you'd have to have a bit of code that would convert their answer into a Boolean of yes or no. So you'd need an if statement in there that turns it into yes or no. But you could, and then if you had a Boolean A that was that answer, you could just do while A is true, and it would stay until A became false. But if you're getting answers from the user, users always type strings, because that's what you're typing in sequences of characters at the keyboard. But that is just a test, just like in an if statement. Anything you could put in an if statements test, you could put in a test here. So you could have ors and ands and nots and stuff like that to build more complicated tests as well. Yes?
I was wondering if it would be bad to
Yes. So what he's asking, so what you could write instead in the while is while true. And what does that mean? Well, while true, the test, you keep going into the body of the while loop for as long as true is true. As long as that test is true, go into the body. So if you just write true there itself, then that says go into the body every time. And that basically says do an endless loop, go round that loop forever. But if you put a break in the middle of the loop, like we did in the for loop, you could use the break to get you out. That's bad practice in general because it's really obscure code. The whole point of structuring a loop like this is so that you can see right at the top exactly how you get out of the loop. If you use a break, you've got to read the whole of the loop body to find out how you get out. So there are some situations when you would do it, but it's use it with caution. And in general, try and avoid using it. For now, practice don't use it, because if you can always manage to do it this way, then you'll be in a position to write better code in general. So I would avoid putting breaks inside while loops, except in very, very rare situations where they can turn out to be an easier situation. The equivalent to that would be having a return inside a while loop if this was part of a method. And again, there are some situations when you would do it, and actually the linear search situation is one situation, which I showed you with a for loop, where it's sort of normal to do it like that. But in more complicated cases, it's better to write a test that's an explicit test that says, this is how you get out of this loop right at the top. Okay? Any other questions? Okay, let me go on to one of the others. Just very quickly, I'll answer another question. I'll leave it as an exercise for you to think about, can you write little while loops that do the others? But just so you've seen two alternatives, let's go on to the third one. Roll the dice repeatedly, adding the scores, keep going until you get more than 21. Well, it's going to be more or less the same. So we're going to have to set the score to 0 at the beginning again. We're going to need a while loop, and that while loop's going to have some kind of test, and it's got a body. We're going to roll the dice each time. We're going to add to the score each time. We don't need any input because basically it's just going to keep rolling dice. But now, what is the test? It's until you get more than 21. Oh, and we've got to do it in as few rolls as possible, so we ought to keep a counter of how many times round the loop we've done. So we want something else that says count gets count plus 1, just so we know how many times we've done it, and we'll need to initialize that. Int count gets the value 0. So what's the test this time? Well, it says roll the dice until you get more than 21. So keep going while the score is less than or equal to 21. Okay, so in this case, it's telling you you keep going until you get more than 21. So that means you're going while it's less than 21 and you stop when it goes over 21. So we keep going while the score is less than or equal to 21, stop when it's more than 21. And again, the body, more or less the same as we had before. This time we're keeping a count because we need to print out the count at the end. That might be what we do at the bottom. Print. You took. Count goes. And again, it's another common pattern for using a while loop. It's not exactly the same as last time. It's not doing a test on something that somebody input. It's doing a test on something that's calculated inside the loop. So anytime you're processing stuff and you've got to do something inside the loop and the test says finish when you've got up to some value, when you've hit some limit on the calculation, it's something very similar to this that you'll be doing. Things to remember: make sure you get the test the right way around. Always remember to set the variables outside the loop and initialize them, and this is where initialization becomes really important. One of the most common ways of getting while loops wrong is to forget to initialize, or to initialize to a poor value, to the wrong value. Okay? And I'll talk about a lot more of this next time. We'll look through some of the other variations of using while loops. But with while loops, the way to do it is basically to get your head around these different patterns and then just spot what problem are you doing, which of these patterns is it. So I still haven't had the register from the balcony. If the register from the balcony doesn't come to me, everybody on the balcony will be absent. Anybody got any questions? And I'll be outside for at least the next half hour, for as long as it takes me to answer any questions anybody's got. And if anybody wants one-to-one help, come and see me again outside.
Procedural programming lecture during reading room?
Yes. I've got a post message about that. Yes, all our classes go on for reading week. Partly because there isn't a lecture in, probably there isn't going to be a lecture in week 11 because there's a graduation ceremony happening in here. So yes, lectures will definitely happen in reading week.
Program you did, or the one with the second program in the array. If you
Yes.
had more than one thing, you broke the loop at a certain point. Once you
Then
find
you
the
would
first
only
one.
find the first one, not any of
How
the
do you
later.
find the rest? How do you assign the variable to the other ones?
So you would need something like an array, and you would just store each new position in an array. Ideally, you would probably want something that was a flexible size, so actually you would probably use something that was a flexible data structure, like, I don't know, lists or array lists or some variation of an array. Or, depends what you want to do with it, it may be you're just printing it out as you go along, in which case you just print it and move on to the next and just keep going until you get to the end of the array. But yeah, it depends on exactly what you want to do, but you would be storing each value in a data structure.